When deploying LoRaWAN networks, you have to dispatch gateways, you have to manage them, you have to update the software and their configuration, and that might be challenging sometimes, and you need to do all of that in a secure way. Azure Sphere could be a solution here. Chris and Yannik are here to discuss how our partner Avnet is offering a mirror edge gateway for LoRaWAN solutions that is supporting Azure Sphere. And Yannik is going to show us how he can change the configuration of his LoRaWAN gateway running Azure Sphere remotely from the Azure Sphere services. So that's today on the IoT Show. Hi everyone, this is the IoT Show. I'm Olivier, your host. Today we'll talk about bringing some Azure Sphere into the LoRa world. And for that we have Chris and Yannik. Chris, Yannik, how are you today, guys?
Hi, good, thank you.
So let's do a quick round of introductions to start with. Yannik, you first. Who are you? What are you doing in life?
Sure. Yeah, my name is Yannik Kopp. I'm a cloud solution architect based in Switzerland, Zurich. Focusing mainly on supporting customers doing IoT use cases.
Okay, we love people like you. You help customers ramping up and then implementing solutions. That's pretty cool. Chris, what about you? What are you doing these days?
Hi, Olivier. I'm Chris Cassidy. I'm a technical specialist at Microsoft. I'm part of the IoT partner ecosystem team based in the UK, and I work with everything IoT.
Nice. So today you guys came up with some explanation, discussions, and then a demo about Azure Sphere being used on the LoRaWAN gateway. And before we jump into how Azure Sphere can help simplify the security or securing these gateways, let's talk a bit more about, Yannik, about LoRaWAN. What is LoRaWAN? Quick refresher. What is the overall architecture? We talk about gateway immediately. So for people who are not familiar, can you give us a little overview of what LoRaWAN is?
Sure, more than happy to. I prepared, or not me actually, shout out to our friends from the Things Network who prepared this little architecture slide that we can quickly bring up. Mm-hmm. So just as a refresher, you can imagine LoRaWAN as a wireless network to connect IoT devices over long range with a very low power consumption. And when we mention like low power consumption, we speak about the years of lifetime of the devices in the field. So typically battery powered devices. And when we talk about range, it's really miles of connectivity that you can cover. Obviously, it's a bit dependent on the topology, but in a rural area, you can really cover miles of coverage with LoRaWAN. So looking at the standard architecture, when setting up a LoRaWAN network, you need to have your own, let's say, gateways in the field, your own concentrators. So they will provide the connectivity, your LoRaWAN connectivity with the antenna equipment. And all of these gateways, they are talking to one central instance, one central brain of your network, which is called the network server. And this component is responsible for basically decoding the LoRaWAN messages received from the end nodes in the field, making sure they end up at the right place, the right application server, which is then responsible for actually make use of the data. So to do a nice visualization on top or nice analytics. And basically, when it comes to the end nodes in the field, we got plenty of devices already available, like off the shelf in the market. So you could just buy them from different vendors to implement your IoT use cases.
Nice. So we'll talk about the challenges, the main challenges that our customers implementing LoRaWAN solutions are facing. One thing you kind of alluded to, but LoRaWAN allows you to have private networks and public networks as well, right? I think it's kind of relevant for the conversation here because your gateway, when you deploy it, you can decide that it's a public one that any LoRaWAN device can connect to, and someone else can have their device connect through your gateway to their own network server, right?
Yeah, that's actually one of the nice things about LoRaWAN, right? It gets these capabilities of providing basically an open source network which everybody can leverage. I mean, this is one, let's say, use case that is already implemented. But other customers, for example, thinking about utility companies or industrial customers who have more, like, let's say, security or data security relevant use cases, they might want to stick to their private networks they have set up completely disconnected from the internet. So it's not Internet of Things, it's more an intranet of things.
Yeah. Yeah, and that's understandable, right? You do want to have your own channel to make sure your own devices and data can circulate, properly and nicely. So, what are the main challenges there, right? We just kind of alluded to some of them, but what are the main challenges customers are facing when deploying LoRaWAN networks?
Sure. I actually draw or have written them down a bit to give you a bit of help there. Just when speaking about LoRaWAN gateways, you have to think about really basically a Linux box that goes out in the field, right? And typically when setting up LoRaWAN networks, you want to cover large areas with coverage. So they're typically mounted in remote places, maybe on antenna towers or rooftops of large buildings, just like places which are not really accessible. So yeah, like the nightmare for a LoRaWAN operator is basically mounting a gateway, trying to update, let's say, the operation system, and then something fails. And then you need to send like a technician out there, dismount the LoRaWAN gateway, bring it back to your lab, reflash it, and so on. So this is a huge hassle for every operator. And then also the security aspect, right? I mean, typically, or some LoRaWAN gateways are out in the field. These are Linux boxes, and they are connected to the internet sometimes. So you really need to make sure you get the latest patches installed on this device. And typically, like, you don't deploy one or two LoRaWAN gateways. Like standard deployments often include several dozens of LoRaWAN gateways.
Okay.
And then, like, there is also like the whole configuration of the packet forwarder, which is responsible of taking the LoRaWAN packages out of the LoRaWAN electromagnetic spectrum and the frequency that is used for LoRa, and translating it into a JSON package. And you might want to change your configuration. Might want to change the packet forwarder or that is targeting a different network server. And this is another configuration where you basically need to access the gateway and basically deploy this packet forwarder then.
Yep. Makes sense.
And
so,
then...
Yeah, and go ahead. You have device management as the last one, right?
Exactly. And for example, when it comes to device management, as I said, typically a deployment involves dozens of gateways in the field. You want to have one central instance to manage your packages, your software packages that get deployed to a device. And this is also a huge struggle for these operators.
Got it. So in a nutshell, if I want to put it super simply, you need to have some way of managing that OS that is basically powering that gateway. And it seems intuitive then that we introduce some secure OS in the fold here, Azure Sphere being one of them. So Chris, tell us a bit about, well, first Azure Sphere, because people might not know what it is exactly. So a little refresher about Azure Sphere and how it can help securing these LoRaWAN gateways.
Okay, thank you. So Azure Sphere is our secure IoT solution for MCU level devices. So what you have with Azure Sphere is three things. You have hardware, i.e. your secure silicon from a number of vendors. You have your software. So we have a secure OS specifically targeted at these devices. And you have a cloud service used to monitor and maintain these devices. These all come together to give you a secure solution for these MCU level devices. So Azure Sphere, in terms of LoRaWAN gateways, what it gives you in this case, first of all, you have the secure OS. So we have this hardened Linux kernel. So there's no passwords, there's no logins. It's a secure Linux kernel provided specifically by Microsoft. Also, we have an update cycle with the secure OS. So on a monthly cadence, Microsoft update your OS with OS updates and security patches. Also, there's a multi-layer approach to the OS. So compared to RTOSes, which are normally targeted at these MCU level devices, we have this multi-layer approach. We have a secure compartment for your applications. So effectively, your applications are sandboxed, and so they have restricted access to the hardware and to the network. Also, we have a secure firewall by design. So you specifically have to specify which IP addresses and which ports you're going to connect to. Otherwise, it's a completely locked down system. And also through Azure Sphere, you have the ability to update your applications remotely in a robust manner. So as I said, the applications run in these sandbox compartments. So if you push down an application and there's a failure there, it's not going to compromise your device and break your device. So I have a diagram here which hopefully explains what we provide with Azure Sphere. So you have your LoRaWAN gateways, which are deployed in the field, and they are gathering sensor data and sending it to the LoRaWAN network server in the cloud. So this is the normal approach which Yannik referred to. We now have the addition of this cloud service, the Azure Sphere Security Service. And what this gives you is two things. You have OS updates provided by Microsoft. As I mentioned, they're provided on a monthly cadence and they're provided for the lifetime of the device. And that maintenance is built into the cost of the chip. So there's not a recurring fee for those OS updates. Also, you have the ability to push down your own application updates. So you can leverage this cloud service to push down application updates to your deployed devices. So using the cloud security service, you get updates to the Sphere OS with OS updates and security patches to ensure that the security posture of your device is maintained. And you're also able to push down your application updates. In the case of the LoRaWAN gateway, you have this packet forwarder. So if you want to push down a new version of your packet forwarder, which may have bug fixes, or a new version which connects to a completely different LoRaWAN network server, that's what you get with the Azure Sphere enabled gateway.
Nice, nice. And on the device itself, on the gateway itself, so the Sphere OS is down there, but you need to run a gateway server, right? It's a piece of software which does the LoRaWAN interaction, I would say, with the LoRaWAN antenna and so on. So is Microsoft providing something there, or is it like you're using an existing stack that is out there on these kind of gateways? And just what's the solution there to run that gateway server there?
So our partner Mirumiko will be providing the packet forwarder applications for the Sphere device. So they will come with a packet forwarder on there, and that will be compatible with the Semtech packet forwarder. And we will also be looking at supporting different packet forwarders that are compatible with different LoRaWAN network servers.
Okay, nice. And one thing to mention is that Azure Sphere Security Service is something that obviously is hosted on Azure. Your network server for LoRa can also be hosted on Azure. Here on the diagram, we said like different clouds and so on. You can host it somewhere else, but you can definitely host it on Azure. We have partners that offer some options there for network servers up there. So how about we look at a little demo here?
Sure. Maybe before entering the demo, I wanted to show you actually our beauty here. I got one on my desk of these LoRaWAN gateways.
Yeah.
Right from our partner produced Mirumiko. You can see the LoRaWAN, the Sphere enhanced Miro Edge gateway.
Yeah, so it's pretty small. It's something that, and I guess you can have enclosures that make it super robust to weather conditions and things like that, right?
Absolutely. I mean, this is now an indoor version. but I'm sure that our partner Miramico also has like an outdoor version in the pipeline.
Yeah.
Because like, especially when mounting it like outside on an antenna tower or something, you want to make sure it's IP67 conform.
Yeah, got it. And interestingly, these little antennas are giving you these miles of range you were mentioning, right? You don't need to be like, when we think about long range for communications, we often think about like huge towers and big, huge antennas, but that's not really the case here, is it?
No, actually, these are indoor antennas. So with these antennas, you probably will be able to cover, let's say, a factory floor or an office building floor. But if you're really looking for miles of coverage outdoors, you need to have like more DBI or larger antennas.
Got it. Makes sense. Cool. Okay, so here you have your Things network instance deployed. Show us how that works.
Okay, yeah, perfect. So at the moment, my Miro Edge gateway is connected to the Things network. I had to quickly unplug it to show it to the camera. Yep. So let me refresh here. Yeah, it's connecting at the moment because I just plugged it in. But typically, yeah, this is a very commonly used network server. So I connected my Miro Edge gateway here. Let me see. Yeah, it's connected. You can see packages are arriving. I actually got a little field tester ready here in my hand. I can send up and downlink packages, and they are well received in the network server. So everything is working fine. Now I might take the decision and say, okay, I've been using and testing my devices I've been building my use case on the Things network. Now I maybe want to switch to a different network server. I have to decide to go with a LoRaWAN network server.
Yep.
And now I want to basically, I need to replace the packet forwarder and the configuration on my Miro Edge gateway. How to do this? So let's switch to Chris to the management portal.
Thank you, Yannick. So if you look at my screen, what I have here in this browser window is a management portal which is connected to the Azure Sphere security service. And what it's displaying here is my tenant within the Azure Sphere security service. So it's an internal tenant, so it has a large range of devices or product groups already listed on the management portal. And you can see at the bottom there, we have a product group for the LoRaWAN gateway. Now what I can do is I can locate those devices in the management portal, and I can deploy a new application to those devices, a new application which will have the LoRaWAN packet forwarder and will connect to the LoRaWAN network server.
Yep. So something we didn't mention, Chris, in Yannick in the introduction. So Chris, where are you calling from right now?
I'm actually in the UK.
Okay, and Yannick, London. And Yannick, where are you?
I'm based in Zurich, Switzerland.
Okay, and I'm in the US here. So perfect. So here Chris, you're going to be deploying onto Yannick's gateway remotely through the Azure Sphere portal and use software update, basically.
Exactly.
Okay.
So first I go to this list of devices. I have a large list of devices, so I'll just search for all the devices in that product group. So I have one gateway registered at the moment. This should be the gateway on Yannick's desk.
Yeah, should be, please. Be that one.
I can just set up a new deployment for that device. So I look at the available deployments, and I have one here for the gateway product, connecting it to the LoRaWAN LNS. So this is the right application package and the right packet forwarder to connect to that network server. So I'll save this deployment. And once that's saved, then that deployment is targeted at that gateway device with the Sphere chip inside. So what will happen now is once Yannick reboots the device, when a device comes up, every time it boots up, it checks in with the Azure Sphere security service, and it will see first the Azure Sphere security service authenticates the identity of the device. It performs remote attestation on all the software components. That's another part of the security posture of Azure Sphere. And then it will download that application update to the device. Once that's downloaded to the device, it will be installed, and then Yannick will have that new application running on his device.
Got it. All what you're doing manually here, as in preparing the update and then triggering the deployment and so on. All of these can be done programmatically, right? And you can also automatically trigger the reboot of that device so that it gets its update. What we're doing manually can be automated or done programmatically, right?
Absolutely. So this management portal is using the public REST API for Azure Sphere. So anything that's done here can be done programmatically. And obviously you can trigger a reboot of the device. And also the device will automatically, after 24 hours, check in with the Azure Sphere security service anyway. So that's something that it does on a daily basis for these updates.
Nice. And if it fails, you'll have a report. You'll know exactly what happened in that update tentative or whatever, and you can take action there. So it's going to take, 2-3 minutes for that device to come back to life and then being changed, right? So let's give it time, and we'll get back as soon as it's done. Cool. So it took something like 2 minutes. So now we're in business. Yannick, do you want to take over here?
Perfect. So if we switch back to the things network server, you can see it's now my gateway is disconnected. So it doesn't connect to this network server anymore. And I can now switch to my other choice, the LoRa network server. And I can see, I will quickly refresh again. Yeah, it's connected.
Nice.
And if I tap into the data stream, let me trigger a few packages here. I got another nice LoRaWAN device here. I can just press the button. Yeah, we see the package showing up. So like super seamless transition with the configuration and
nice.
Like just to switch
really
the network
nice.
servers.
And all of that integrated in terms of management and configuration, thanks to the Azure Sphere OS and services. If you had to do that with one of the existing solutions, I know some partners are offering, Linux OS management and configuration, but very often it's a combination of different tools, right? Of different platforms, and it can make that a bit complicated. Am I right there?
Yes, there are other options out there in terms of managing your device, but for a lot of solution owners to do that, there's a lot of work involved to develop that, to maintain it, as you say. It may comprise different components that you have to maintain. With this solution, with Azure Sphere, you're outsourcing the security maintenance of your device to Microsoft.
Nice, beautiful. And you mentioned that already, but I think it's interesting to double down on this. Customers want to deploy LoRaWAN. They like to just get these gateways off the shelf. And in that case, our partner Avnet, right, has this solution, the Miro Edge gateway that already supports Azure Sphere on it and so on, right?
Yes, Avnet have a landing page for that product. You can go there. You can find out more information about the device. You can get a demo of the device and get further information.
Great. So let's bring that URL just below here, aka.ms/IoT Show/Miro Edge. So that way you guys can go there, learn more about that Miro Edge gateway, get in touch with Avnet, have them demo that for you, and then just leverage Azure Sphere for your LoRaWAN gateways. Chris, Yannick, thanks a lot for your time today. It was a nice and insightful demo and discussion that we had. And everyone, thanks for watching the IoT Show. Hope to see you soon here. Bye, guys.